so we are on number 23, is that right?
Yes.
Okay. Alright, so here we're talking about Starburst candies and Jolly Rancher candies. And it says the bag of Starburst candies contain 80 pieces and 12 are cherry flavored. And the bag of Jolly Ranchers contains 70 and 14 of them are cherry flavored, which is the best flavor. Assuming that these are truly random assortments, does this provide evidence that Starburst and Jolly Ranchers have a different proportion of cherry flavored candies? Okay, so are we dealing with means or proportions? Okay, and it seems clear that we're dealing with proportions. And do we have one sample or two samples? We've got two samples. Okay, so we're dealing with proportions, and we have two samples. All right. And then, and right there, the first question, it talks about write the appropriate hypotheses. So we know we're dealing with a hypothesis test, okay? So it says, what should the hypotheses be? Okay, so it says for two sample proportions, the null is this, okay? And this is always the case for two sample proportions. The null is always P1 minus P2 equals 0, okay? And then the alternative is that P1 minus P2 doesn't equal 0, is greater than or less than 0. Okay? So what should we use here? Okay. Well, the question says, does this provide evidence that Starburst and Jolly Ranchers have a different proportion of cherry flavored candies? So different, we would use does not equal. Okay, so we have a two-sided test. All right. And then it says, what is the value of P hat? That's 24, question 24. All right, well, let's just list off the data that we have, okay? I've got group 1, which is Starburst, and group 2, which is Jolly Ranchers. And here my N is 80, and the number of Jolly Rancher candies is, or cherry candies is 12. And over here, the number of candies I have here is 70, and the number that are cherry flavored is 14. So this is just data straight from the problem. My overall P hat then is going to be x1 plus x2, the total number of cherry flavored candies divided by the total number of pieces, okay? And that is also written in our guide. It says for two sample proportions, you need to figure out P hat, add up the total successes, and divide by the total observations. So I have 12 plus 14 divided by 80 plus 70. So I have 26 over 150, and that turns out to be 0.1733. That is my P hat. What is the test statistic? So I've got to figure out my standard error here, okay? My standard error is P hat times 1 minus P hat over 1 over N1 plus 1 over N2. that's going to give me my standard error. Okay. So my standard error, that's some crazy number. I get 0.0619. 619, but this is not my test statistic, that's just my standard error, okay? So the statistic is equal to P1 hat minus P2 hat. So again, if you're not sure, it's observed minus the null. So the observed is P1 hat minus P2 hat minus the null, which is 0 divided by my standard error, okay? Test statistic is always in the form observed minus null divided by the standard error. The observed for two sample proportions is P1 hat minus P2 hat, and the null is 0, and the standard error is this. So P1 hat is 12 over 80 minus P2 hat, which is 14 over 70. Okay, minus 0 divided by 0.06195. And when I do this, so do the numerator, figure that out, then do the denominator, I get negative 0.81 as my test statistic. All good? Alright, so now I have to go to the z-table. So I go to my z-table, and we look up negative 0.81, right? So I go to negative 0.01 in the z-table. Z-table, right? Anytime you're dealing with proportions, always the z-table. Proportions will always be the z-table. That's also written right here, okay? Always also written right here. And then, so the number in my tail is 0.2090. Okay, so that's going to be how much I have in my tail. Is that my p-value? No. No. What do I have to do to get my p-value? I've got to double it, right? Because I've got a two-sided test, right? Because of the not equal sign, I got negative 0.81, and I have 0.2090 over here. So it's a two-tailed test, so I've got to double that. So I double it, and my p-value is equal to 2 times 0.2090, and I get 0.4180. This is my p-value. Okay. On the quiz last week, a lot of you guys made mistakes. You guys tried to give me a range using like the t-table or something. Don't do that. When we're dealing with z-scores, or when we're dealing with proportions, we're dealing with z-scores, and our p-values will be numbers that we look up in the z-table. Okay, maybe sometimes we double them, like right here. So what is our conclusion, and what does that mean? That's the last question here. All right, our conclusion is that we do not reject the null hypothesis. Okay, my p-value is bigger than alpha. P-value is bigger than 0.05, so I do not reject the null hypothesis. And I do not have evidence cherry candies is different between Jolly Ranchers and Starburst? Greater than P2? Oh yeah, not equal to P2? Yeah, you could do P1 equal to P2 rather than P1 minus P2 equals 0. That's also acceptable. Yes. Yes. Alright, let's look at 28 through 33. It says researchers want to know if drinking caffeinated drinks improves reaction time. They randomly select volunteers and in a blinded experiment give some of them caffeinated drinks and others non-caffeinated drinks. Then they record reaction time. And it says 30 people drank a drink containing 300 milligrams of caffeine, and their average reaction time was 580 milliseconds with a standard deviation of 110. And the other had 25 people drinking 0 milligrams of caffeine. Their reaction time was 640 milliseconds with a standard deviation of 130. Is this evidence that drinking caffeine improves reaction time? Alright, so are we dealing with means or proportions? Means. Do I have one sample or two samples? Means, two samples. Alright, it says, what should our hypotheses be when we're performing a hypothesis test? Right. Again, you can always look at your study guide if you're not sure. And so here, our null hypothesis should be mu1 minus mu2 equals 0. And our alternative is going to be mu1 minus mu2 something 0. Okay, improves reaction time. Okay, what does it mean to have a better reaction time? It means you're faster, right? So the time for you to react, is that going to be more time or less time? Less time, right? So better reactions means you take less time. Alright, so should mu1 minus mu2 be greater than 0 or less than 0? Less than 0, okay? Because mu1 is the people who had caffeine. Their time should be smaller than the people who didn't take caffeine. So those are the hypotheses that you should have. What is the observed difference between means? Well, the observed difference, again, this appears in your study guide. Halfway down, the observed value, and under what is the test statistic? The observed value is this. Okay, the observed value is x bar 1 minus x bar 2. So in that case, this is equal to 580 minus 640. My observed difference is negative 60 milliseconds. Asks, what is the resulting test statistic, or t statistic, okay? So for a test, our t statistic here, observed minus expected, divided by the standard error, okay? Well, the standard error, what is the standard error? S1 squared over N1 plus S2 squared over N2, okay? Again, all of this is written on your study guide under what is the standard error? Square root of 110 squared over 30 plus 130 squared over 25, and the number there is 32.85. So my test statistic, the observed value I got was negative 60. What is my expected value? It's 0. It's whatever's in the null hypothesis. 0, and my standard error is 32.85. So I get negative 1.826. Hang in there.
Can you give us another example? Because that's kind of true. Better reaction to less time. Is there anything else that would be like that?
Maybe. I'm not trying to be tricky. It's just, I guess you just have to sit and think what better or worse or more or less might mean. Okay. So if it says, did things get stronger, then the strength should go up, whatever that means. Okay. So yeah, I mean that one's it's true. You got to think for a second. Okay. All right. So what is our p-value? Okay. 31. Our p-value. So our test statistic is negative 1.826. How many degrees of freedom do I have? Okay. I've got two samples. The smaller one is 25. So my degrees of freedom is 25 minus 1. I have 24 degrees of freedom. Okay. I think my table does indeed have 24 degrees of freedom. And I'm looking for where 1.826 fits. Okay, so I go to 24 degrees of freedom. And the numbers I see are 1.711, which corresponds to 0.050. And the other one is 2.064, which corresponds
number 30?
0.025. Did I skip?
Yeah.
No, 30's right there. Okay. All right. So my number 1.826. Okay. If you get a negative number, just ignore the negative sign for now. So 1.826 is in between there, which means my tail is in between 0.025 and 0.05. Okay? Can I use that as my p-value? Yes, right? I've got a one-tail test, so the area in one tail is my p-value. I don't need to double it. So my p-value is between 0.025 and 0.050, okay? Maybe it'll be written this way, 0.025 is less than the p-value, less than 0.050, okay? These, you gotta get comfortable reading numbers, whether they go increasing or decreasing, all right? It's the same thing. So that is our p-value for number 31. Any questions? So far, so good? 32, what is our conclusion? So let's assume it says, assume alpha is 0.05, or use alpha equal to 0.05. What is our conclusion?
You reject.
I reject. My p-value is less than alpha, so we reject the null hypothesis. Alright? And that means we have evidence that caffeine improves reaction time. And the last for that page, if your previous conclusion is wrong, what kind of error did we make? Type 1, we rejected the null hypothesis, and if that was a mistake, that's a type 1 error.
Isn't there type 2 error? What is that?
Yeah, type 2 error happens if we didn't reject the null, and that was a mistake. If it was a mistake not to reject the null, then that's a type 2 error. Alright, 34. In a certain city, is this okay? Everybody going okay? Alright. 34. In a certain city, a study was conducted to see if the police department had a different proportion of minority employees than the fire department. Researchers randomly selected 200 employees from both the police and fire departments and took note of whether the employee was a minority or not. Okay? Are we dealing with means or proportions here? Proportions, right? Whether you are a minority or not, that is a categorical variable. And so we are dealing with proportions. And do we have one sample or two samples? Two samples. So we got two sample proportions. Okay. So it says, well, for this hypothesis test, what are the hypotheses? Alright, again, anytime you're dealing with two proportion hypothesis tests, it's P1 minus P2 equals 0, or P1 equals P2. And what is the alternative? Not equal to, right? It says different proportion of minorities. We're not suspecting that one is bigger or smaller than the other. So we have P1 minus P2 not equal to 0. What is our P hat? P hat? Well, let's list off our data. So group 1 is the police department, and group 2 is the fire department. So in group 1, the number in our sample, N1, is 200, and how many were minorities? 80. And in group 2, the number was 200, and the number of minorities, 50. So our P hat, 80 plus 50, I get 0.325. Let's try moving on. 36. Calculate the test statistic, okay? So first we got to figure out our standard error. P hat times 1 minus P hat, 1 over N1 plus 1 over N2. 0.325 times 1 minus 0.325, 1 over 200 plus 1 over 200. And when I do this, I get 0.04684. That's not my test statistic, that's just my standard error. The test statistic is Z. Alright, so be careful, you know, maybe one of the wrong answer choices will be just the standard error, okay? That's not your answer to the test statistic, that's the standard error. So this is P1 hat minus P2 hat, what we observed, minus what I expected, which was 0, divided by my standard error. So what I observed, 80 over 200 minus 50 over 200. That was the observed difference divided by, minus what I expected divided by my standard error of 0.04684. This turns out to be 0.15 divided by 0.04684. And I get 3.20. As my z-score, my test statistic. Yeah, this is my test statistic. So what is my p-value? Okay. Well, I have to go to my z table and I'm going to look up 3.20. Alright, and when I do that, how much is in the tail? When I look up 3.20, I'm going to get 0.9993. Okay? But how much is over there is 1 minus that, so I have 0.0007 in the tail. Okay? Is that my p-value? No. I have a two-sided test because it says not equal to, right? So I've got to look over here, and I'm going to have the same amount, 0.0007. So my p-value, because it's a two-sided test, is equal to 0.0007 times 2. My p-value is equal to 0.0014.
What if the line 3.25 is 0.9994?
But my number is 3.20. Yes?
Oh, 0.0012. Are there going to be like similar?
No, it'll. The answers will be very distinct, okay? So yeah, because of some rounding issues, maybe you get 0.0006 or 0.000 or something, okay? The answer choices on the final will probably be 0.0014 and then something like 0.003 or something distinctly different. I'm not going to be off by 1 or 2 tiny little pieces, okay, to make sure you rounded the same way I did, okay? That's not the point of statistics. I'm not worried about how you rounded, okay? Yes, Jonathan first.
Why did you multiply by 2?
I multiplied by 2 because I have a two-tailed test, and I know I have a two-tailed test because I have a not equal sign. Okay, how do I know I have a not equal sign? Yeah, because in the question, it says, do we have evidence, is this evidence that the two departments have different proportions? Okay, so the keyword there is different, which doesn't say, are there more minorities in the fire department or something like that? Okay, yes?
Is the rule like always, if you get a positive z-score, do you always subtract by 1 if it's on the positive?
For a two-tailed test, yes. Okay, for two-tailed test, you're always looking to the side with the tails. So Yeah, with a two-tailed test, if you look at 0.9993 and you doubled that, you would get 1 point something, right?
And other than that,
And your
it's
p-value can
decided
never be
on-
bigger than 1.
Other than that, it's decided on how the question is written, like more
Yes.
than or less
Yeah.
than.
Exactly. Alright, so if this is our p-value, 38, our conclusion is to reject the null hypothesis because our p-value is less than alpha, and that means we do have evidence that the proportion of minorities is different. Alright, and here it says, in the context of this problem, what does it mean to commit a type 1 error? Well, to commit a type 1 error is to reject the null hypothesis while the null hypothesis is true. That means we believe there is a difference in the proportion of minorities. But the truth is, there is no difference. Sorry, just suddenly started feeling lightheaded. I think it's just been a long day. Okay. We're almost done. It's good news for everybody. Number 40. Potatoes sold at the grocery stores is in 5-pound bags, and you decide to take a random selection of 10 bags, and you find that the average weight is 5.2 pounds with a standard deviation of 0.3 pounds. Is this evidence that the bags at the grocery store have a mean weight different from 5 pounds? The following questions refer to a 95% confidence interval. Okay. All right, number 40. How many degrees of freedom do we have? 9. Oh, well, first off, are we dealing with means or what? Means, yeah, means, and how many samples do I have? 1 sample, okay? Only 1 sample. So always figure that out. Degrees of freedom is n minus 1. So I have 10 bags, I got 9 degrees of freedom. Okay, what's the center of the interval? Center of the interval is x bar. X bar, okay? Again, all of this stuff, you can go down the study guide and you can figure out where you stand, alright? And it tells you, okay, well the center of the interval is x bar. So what's our x bar? 5.2 pounds. There's your answer. Number 42. What's the standard error? Okay, well here we're going to look up 95% confidence in the t-table for 9 degrees of freedom, and the number there is 2.262. Oh, I'm sorry. That's not the question. It says, what is the standard error, not the critical value? Ha ha ha. Okay. Getting mixed up here. Okay, standard error, S over the square root of n. So, in this case, 0.3 pounds divided by the square root of 10, and the number there there is 0.0949. And 43 is what is my confidence interval. There I have 5.2 plus or minus the critical value, which we looked up and we said was 2.262 from our T table, multiplied by my standard error, 0.0949. And this gives me 4.985 on the low end to 5.415 on the upper end.
I don't get that part.
You don't get which part?
Oh, okay, so you find the margin of error, which helps you find that.
Yes, so I'm going to do this and I'm going to get 5.2 plus or minus 0.215. Okay, if I do the multiplication, I get 0.215.
Okay.
Alright, and then I do 5.2 plus 0.215, and that gives me this. And I do 5.2 minus 0.215, and that gives me this.
Why do you have that time while you do it?
Okay, because the equation is x bar plus or minus my t star times my standard error.
Okay.
Okay, so what's my standard error? 0.0949.
Yeah, great.
Okay. And so 44 says, what conclusion do we make? Okay. So, because we're asking, is this evidence that the bags at the grocery store have a mean weight different from 5 pounds? Well, 5 is in my interval. So I do not have evidence that the mean weight is different from 5. Last page of the practice final. This is .45. A fair die should land showing the number 4 1/6 of the time. You roll a die 100 times and count how many times it lands on the number 4. It lands as the number 4 20 times. Is this evidence that the proportion it lands for is different from 1/6? Okay, means or proportions? Proportions. One sample or two? One sample. How do I know it's one sample? Well, I try to figure out what my n is. What is my n? 100. Is there another n? There's no other n. I can only figure out one n, so my n is 100. Okay? What is the hypothesis here? Yeah.
N is 100. What is
20 would be my x. Okay. Alright, here I'm making a proportion on what?
How many times you get?
Yeah, okay, so what symbol do I use there? For the proportion of times it lands on 4. P. Okay? And again, if you're not sure, go to your study guide and say, I have one sample. I mean, for proportions, I'm dealing with one sample. And it will say P is equal to some number. What is that number that it should be equal to? 1/6. Okay? So you might write it as 1/6, or you might write it as 0.16667. And what is my alternative? P does not equal 1/6. Okay, that's coming from the problem. We want to know is the proportion that it lands on heads different. What is my sample proportion? 20 over 100, okay? It landed 20 times out of 100 rolls. So my sample proportion is 0.2. Alright, what's the standard deviation of your sampling distribution? That's a fancy way of saying the standard error. Or, not quite the standard error, okay? This is, if the null hypothesis were true, what is the standard error that I'd be using? Okay. This is, do I use P or P hat? P. P because I'm doing a hypothesis test. Alright, again, look at your study guide. When you're doing a hypothesis test, you're using P. When it's a confidence interval, you're using P hat. So I got P times 1 minus P over N. And what is the P that I'm looking at? 1/6. And 1 minus 1/6 over N, which is 100. Alright. And so I get 0.03727. Okay.
How do you calculate that? 1 minus 1/6.
You just punch it in your calculator, use parentheses, it'll do it. Okay.
Which way would you like us to do that? Like, would you rather us leave it as a twin, or would you like us to do it?
It doesn't matter, alright? Well, it's multiple choice.
Yeah.
Okay? So, your answer choice might be a decimal like this. Your answer choice might be written like this. Okay? I hope it's okay. I think it's okay. So 48. Okay, so we're going to do observed minus expected. So what I observed was a proportion of 0.2. What I'm expecting is 1/6. Okay? And my standard error is 0.03727. So the number I get there is 0.89. Yes. Yeah, standard deviation of the sampling distribution when we're talking about a hypothesis test is the same thing as my standard error. Okay? For a hypothesis test. Okay, so in this case, what is my p-value? Oh, no. It says, it doesn't even ask the p-value. It says, do a two-sided hypothesis test with alpha equal to 0.05. Alright, so I look up 0.89 in the z table. And the amount, when I look it up, I get 0.8944. But that's not how much is over here. I got to do 1 minus that, and I get 0.1867. No, what is that? Yeah. 0.20? No. Why is my math all funny? 0.1067. 0.1067. Did I do my math wrong? Hang on. I gotta check my z table. I think I screwed something up. 0.89 is 0.8133. 0.8133. I don't know why I have the wrong number. Okay, so when I do that, I get 0.1867. Alright, and because it's two-sided, I'm going to have 0.1867 over here also. So my total p-value is equal to 2 times 0.1867. And my p-value is 0.3734. So I do not reject the null hypothesis. Alright, is that good?
When we have two tables, can't we just, we look up the negative number first, right?
Yeah, you can. You can just look up the negative number and then double it. You'll get the same thing. That's absolutely correct. Okay, so so these ones we'll just read through them and I'll tell you the answers. Major League Baseball wishes to conduct a survey of its players. Instead of trying to create a list of all the players from all their teams, Major League Baseball decides to randomly select 4 of their 30 baseball teams. Then they will survey all of the players on the 4 selected teams. What kind of sampling is this? Cluster sampling. Cluster sampling, right? They don't have a list of everyone. They have a list of subgroups, in this case teams. And they're going to randomly select some of the teams, and they're going to look at everybody on the team. Okay? Oh, I wonder how the Dodgers did today. Okay, number 51. It says a company wants to survey its employees. They take a master list of everyone in the company, and they randomly select 100 of them for the survey. What kind of sampling is this?
Simple random sampling.
So the key here is it says you have a master list of everyone. Because of that, it's going to be simple random sampling. When you have a list of everyone in the population, you can do simple random sampling. Number 52, a toll bridge wants to survey the drivers who use the bridge. Instead of trying to ask all of the drivers, they decide to stop every 10th car that passes through the toll booth, and they ask for the driver's opinions. What kind of sampling is this? Systematic, right? You're going through a line, every 10th person is selected, or every whatever person is selected, that's systematic sampling. Yeah, Lucy?
For number 50, okay, that was the one about the baseball teams, right?
Mm-hmm.
So wouldn't that be stratified sampling, because cluster sampling has diversity within...
There's diversity within a baseball team. Some people are pitchers and some are batters, some are, you got infielders, outfielders.
I put stratified sampling.
Okay, so okay, so stratified sampling wasn't one of the examples, but you gotta know stratified sampling also for the final exam. What is the key criteria of stratified sampling?
They all share a common trait.
They all share a common trait, and you are matching the proportions of your sample to match the proportions of each strata in the population. Okay? The key for cluster sampling is that you have a list of all the clusters. Okay? And for baseball teams, we've got a list of all 30 baseball teams. Okay? So that's the difference there. Okay. All right. So those types of questions will cover about 80% of the exam. We have a few questions left. All right. And these are just some examples that I put on the practice final. We can talk about some other examples here that may or may not be on the final exam. Okay. All right. So for example, a bar chart is used for what kind of data? Bar chart is for categorical data. Okay. What else do we use for categorical data? No. Contingency tables or frequency tables. Those are for categorical data. Frequency tables, contingency tables, or two-way tables, whatever you want to call them. Categorical data. What about numeric data? Histograms are for numeric data. What else? Dot plots are for numeric data. Box plots, numeric data. Yeah. Okay.
So will there be any regression?
There might be regression there, but there will not be any calculations. Okay. No calculations from the. Yeah, I'll ask questions about things like. I don't know. I gotta. We'll think of something here. Okay. So in a normal model, approximately what percentage of data are within 2 standard deviations of the mean? 95%. How much is within 1 standard deviation of the mean? 68. 3 standard deviations? Almost all. 99.7. Okay. What do you need to define a normal model?
The 99 was what?
99.7 is for 3 standard deviations. No, what do you need to know to define a normal distribution? You need to know the mean, the center, and the standard deviation, okay, for a normal model. You need to know the mean, the standard deviation. What's the definition of a z-score?
Are these uncovered?
These aren't. I'm just calling these out, which might be helpful.
How many standard deviations is from the mean?
What's the definition of a z-score? Yeah, how many standard deviations you are from the mean. Alright, number 55. The intercept in linear regression would be our predicted value when x has what value? When x is 0, right? The intercept is what we predict when x is 0, okay? What is the slope? What's the definition or interpretation of the slope? Yeah, it's for every additional point in x, we expect y to change by the slope. Alright, if the probability of A and B happening together is 0, then A and B are mutually exclusive or disjoint. Okay? Mutually exclusive or disjoint, those are the same thing. Alright, don't say independent. What does it mean to be independent?
They don't have any.
Yeah, it means the probability of A given B is equal to what? No? If they're independent, then the probability of A given B is equal to the probability of A, right? The probability of A is the same whether B has happened or hasn't happened. Okay? If they're independent, can they be mutually exclusive? No, it's impossible. If they're independent, they absolutely cannot be mutually exclusive. If they're mutually exclusive, they cannot be independent. For a quantitative variable, or numeric variable, if there's only one peak in the histogram, what do we say that tells us about the shape? Unimodal, right? What does it mean for something to be symmetric?
Normal.
Not necessarily normal. It means when we have points on this side, we expect just as many points on the other side. What does it mean to be skewed left? Okay, so skewed left, it goes like this, right? But what does that mean? Would I have outliers on the upper end or on the lower end, or what?
Lower.
I would only have outliers on the lower end, right? I wouldn't have any outliers on the upper end if it's skewed left, okay? Just if it's skewed left, I might have outliers on the lower end, but I would have no outliers on the upper end, okay? If it's skewed left.
Because it's like the pointy part's to the left, right?
I'm sorry? Yeah, because the tail, the pointy part is to the left. Yeah, the skewer is on the left-hand side. And just the flip for skewed right. Alright, which measure of center is not heavily influenced by extreme outliers? The median. The median. The median's not influenced by outliers. Okay? What can we say about the mean?
It is.
Okay, mean is influenced by outliers. What else can we say about the mean? What's one interpretation of the mean? The average. It's the balancing point in our data. What else can we say about the median? The mean is the balancing point. The median is the center, the middle point, where half are larger, half are smaller. What percentage of data is smaller than Q1? 25%. What are some measures of spread?
The range.
IQR, the range,
The standard deviation.
standard deviation. Okay, so these are some basic concepts. I mean, there might be some things on there that we didn't talk about. I don't know what's off the top of my head, but I think that's pretty good. All right, you can review that section, and that's that. Okay, we'll finish a little early. We'll see you guys next week. Good luck studying. Please do study. This final exam counts for a lot, so please study.